Good morning, students. Next, Unit 2, Reinforcement Learning, Finite Markov Decision Process. Uh, let's move on to the Finite Markov Decision Process. So, what is mean by Finite Markov Decision Process? This is one algorithm. These are also the formulas used in the RL, Reinforcement Learning Model. So, how to that model decision making problems where the environment is modeled as a finite set of states, actions, rewards, and transition probabilities. So these four kind of this comes under the process of FMT. So what are the components of FMT? The components of finite MTP, that Markov decision process. Markov is one author need that algorithm to implement in reinforcement learning. How that algorithm is implement means to find the environment model in set of state, set of action, set of reward, and set of transition. So set of A, S of A plus S of R plus S of T plus S of P. These are and all probabilities. So what are the components of used in this? Find it MDP. So the state of S is find the infinite state of S. S is equivalent to S1, S2, Sn, whether it is where the agent can be at the given time is present. The status starting the reinforcement that I already told that game. No, you have to remember. You have to mention that game. Starting that state of S, find the set of states. Yes, S1, S2, Sn, where the agent is given time to complete the state. And next process is action. Action is nothing but A. So the A of the set of action A equivalent to A1, A2, Am. So the n number of its continuations not go. It limited period will the process will become to implement there in the formulations. Okay. So the S1 plus A1 and S2 plus A2 and Sn plus An is you have to calculate this, and we have to implement the formula to calculating the other processor. And next one, the action, what we can done means agent can take the each time. So status is given time means agent will propose the status is for given time, but action will take each time to process the formulations. Okay. Next, the transition probability, what we'll do now, P is a function that specifies the probability P of S bar S of A of the transition to state S when action is taken in the state S. So the state S and action A and transition probability B. So SAB, the three considered of the process is going to implement how the given time to complete the target to the agent and access the each and every status to complete to the target to the agent, and the probability becomes the functions is move on to the status S and action A, the taken status S to the probability to transition of specific function. So these are comes under to the environment. To loss complete the game process to complete the environment. Okay. So what are the solutions of methods find it MDP? So what are the solution we have to find there? S and A. S, A and P. So we are implementing value iteration that interactive algorithm compute the optimal value function V star S. V star S is nothing but value iteration. So value iteration into state which represent the expert return starting from state S under the optimal policy. So students listen carefully. V star S is nothing but V is a nothing but value, S is a state, A is the action. So these are you have to size of parameter. We already know the GBT, no, that we have we are compared to this find it MTP. So maximum size of R is a reward. So reward it's processing S comma A plus lambda S emission of P S bar S comma A B star S dash. So V star S dash is a value iteration update the value function until convince. So the value iteration is a solution method. Next, the Q learning and policy iteration. These are also the algorithm implement to the Q function as S comma A. They represent the expected return starting from state S take action A. Therefore, the following policies. So policies alternate between policy evaluation, improving the steps. These consider the solution method of find it MTP. So thank you, students. Next topic will continue other tomorrow. Thank you.